Yeah, I think the jury, to be fair, the jury is still out on whether closed photobioreactors or open raceway systems are the best system to produce algae. And you've hit on a couple of important issues. So the advantages of the open pond system is it has a very low cost in terms of capital expenditure, of course, and a low energy cost. You don't have to pump the water through it as much resistance as you would in a closed system, of course. If you have a contamination in an open system, it's going to be easy to clean it up. On the other side of the equation is that you have a lot of water loss associated with open pond systems, potentially much greater than in a closed system. And the productivity of closed systems has been demonstrated over and over again to be much higher than in open systems. However, in closed systems, I think it's the capital expenditures that we're most concerned about, and also perhaps the issue of contamination. So if we have a weedy algal species or a bacterial contaminant or a viral contaminant, how do we control that in a closed system without taking the system entirely apart? And so perhaps hybrid systems which have disposable bags may be some sort of intermediate solution. So we're looking at, actually in NABS is looking at both models side by side to see how well they compare.
Yes, way back.
So the question was, are we addressing the issue of dewatering? And within our consortium, NAB consortium, yes, we are. We have, I believe, 5 different technologies that address both dewatering, harvesting of the algae, dewatering of the system, and actual extraction of lipid. Technologies such as acoustic focusing, dielectric systems that help us move the algae from one place to another very, very efficiently. Disruption technologies such as RF and acoustic forces for disruption of the algae, and actual forcing of separation of lipid and water layers.
Yeah, and I might add that here at the Danforth Center, we're also focusing on a technology called milking, which allows one to continuously extract the neutral lipids without killing the cells. And so it's analogous to the feedlot with cattle, where we can fatten them up and then milk the oil out, send them back out to pasture, they get fattened up again, and then we recycle this. The advantage of this is that we don't have to regrow that biomass to produce that oil, and so there are considerable time savings and cost savings associated with that. One other important point is that these technologies that Dr. Olivares has mentioned and I've just discussed are all continuous flow processes. They're not batch processes. And in industrial settings, that you accrue many advantages by having a continuous flow process.
Now I want to, yes, go ahead.
From the health, well, there are concerns there actually with the health risk associated with growing algae. There are algal species that are toxic. There are a number of cyanobacteria and red algae that produce toxins that could be problems if those toxins got into the water stream or into the food stream. So we're of course not using those particular species of algae to produce oils. We'll be monitoring the ponds to make sure those weedy and noxious species do not dominate or infect the ponds, and then we're developing technologies to control that. One other aspect, though, of all these technologies is that a number of co-products are going to be produced that'll help offset the cost of producing the oil. And one of those co-products is animal feed. And so the animal feeds will have to be tested to be sure they're safe for animals to consume.
You mentioned something that I want to briefly raise. Mostly we've been talking about algae as though they were just algae, but you've mentioned now particular types of algae. I understand there are thousands of types of algae. Presumably you're hunting for the most oil-rich or the most energy efficient or whatever. Beyond that, are you working to genetically modify algae to make it even more productive, or maybe make it much less toxic? But is genetic modification a part of the algae fuel plan?
Oh, very much so. It's really the focus of CABS. Also, the Air Force projects here is to genetically engineer algae to improve their biomass yield, the quality of biomass that can be used for animal feed, the amount of oil that's produced, the type of oil that's produced, and in addition, their volatile hydrocarbon fractions that are part of fuels, particularly gasoline and aviation fuel, that we hope to be able to eventually produce using algae as well. Although that's not required, it may help reduce the cost. So GMO technology, we estimate, can add 2 to 3-fold increase in productivity in the near term, and it'll be part of making this economically viable.
So in my simple language, one can imagine a biodiesel algae and an ethanol algae and maybe a butanol algae.
Well, there are companies pursuing that strategy, yes.
You make it sound like I shouldn't buy stock in them.
Well, it's a little premature, maybe.
Like everything I've done, probably. Yes.
Follow up on your GMO question. Can you comment on where you think you might be able to go with the GMO algae? Are you closed system versus open system? Time to market? I certainly fully agree that you can get a more efficient algae that way, but how does it fit in with the overall economics of trying to get it actually out there?
That's a big black box right now. Currently, there are no federal regulations on GMO algae, although we expect those very soon. But here at the Danforth Center, we're very actively engaged in conducting field trials on genetically modified plants. So we're very familiar with the regulatory framework, how to move it through the application and approval process, and we have relevant experts from the industry to help us in that regard. But that being said, how much will it cost? It probably will be relatively expensive since it's new, at least the first time through. How do we manage it? Well, we're looking at biocontainment strategies such that the GMO algae will not be able to survive if they did escape from ponds, and so we anticipate that the federal regulations will require some sort of biocontainment strategy as part of the process of approval for GMO algae.
If I may add something,
Sure.
I think it's not just from a federal standpoint, but also a regional state standpoint. Regulations need to change in order to accept GMO introduction into any area. We're seeing that already with land-based plants. We should expect it also with algae.